Hi you guys, Miss Ann here. Welcome to my very first two-part episode. We are going to talk about today when Miss Ann went to the day camp at the rec department last Friday, and we did some explosions at the rec camp with Miss Denise, which if you watched my promo video this morning, we talked about. So this is the first episode of my two-parter. This one is called Elephant Toothpaste. So how you make elephant toothpaste is that you need hydrogen peroxide and yeast. Those are the two most important parts of making elephant toothpaste. And they call it elephant toothpaste because it kind of looks like toothpaste when you do this experiment, because what we're doing is a chemical reaction, and it's an exothermic reaction where we're trying to break down the hydrogen peroxide. And usually that happens very slowly. And if you guys know about hydrogen peroxide, maybe you pour it in a cut to clean it out or something, it gets a little fizzy. And we are just trying to make that reaction be much bigger and break down the hydrogen peroxide faster. And doing that, we add yeast, which is what happens in this video, and you're gonna see it. And we're actually playing with some kids this time. Social distancing, of course, but we're gonna try to have some fun with each other in person, which hasn't happened for a really long time. So I hope that you guys can enjoy this video. You get to see all sorts of funny stuff. And remember, this is a two-parter, so you have to wait until the end of this episode and I'll tell you what part 2 is. So welcome to part 1, Elephant Toothpaste. Let's go.
Has anyone ever heard of this term called H2O?
No.
No? Yes? Maybe? Yeah, H2O.
Yeah, I heard it before.
Do you know what it is? Do you know what else H2O is called? Anybody?
Water.
Yeah, okay, my friends, yeah. Water, yes. Okay, you guys. Okay, so, yes, H2O is water that you guys drink every day, right? Mostly? Yeah? Hydrogen peroxide is H2O2. So it's mostly made out of water, but it has extra oxygen in it that makes it kind of bubbly. So this does not look like regular hydrogen peroxide that you might pour on a wound because, and I'm wearing gloves, because this is the hydrogen peroxide that's a much higher level. This is 9%, which is 3 times as strong as the stuff that you get in the, at like the grocery store or whatever. And this is 12%. So how many more times as strong is 12 than 9?
4.
Well, then 3, but yes, you're right. That's what I meant. You gave me the right answer from what, not the question I asked. But anyway, but the one I wanted, the answer I wanted. So, we are going to try this with both the 12% and the 9% to see which has a better explosion. What do you guys think is going to have a higher, bigger explosion? The 12 or the 9? 12? What do you guys think? 12? You guys? 12? Okay. So, what we're going to do is we are going to have a chemical reaction, you guys. And I'm going to put this out so that we don't wreck the grass and Ben doesn't yell at us or anything like that. So, to do this, we are going to use a regular water bottle that I cleaned out. And in it, I'm going to pour a half a cup of this hydrogen peroxide that they use for like beauty and like to dye your hair. This is where I got it. Does it look like more like half a cup now? Sorta. All right. Oh. Got my handy dish. Oh. in it. What do you think? Is that pretty good? Yeah? Yes? All right, and do you guys feel like we should put some color in this? Yeah? What color do we want? Blue and green? How about blue and green? We'll have an opportunity to do it later. I think we'll just do 2 for right now. So we're going to take food coloring. This is just to make it pretty. It doesn't do anything. And squirt it down the sides a little. We said blue and green, right? Alright, so, but it's not doing anything, right? You guys are watching it. Is it doing anything right now? Can you look at it while I'm pouring this thing? Is it doing anything interesting? Yeah. So right now, the hydrogen peroxide is like what they call inert. It's not doing anything. It's being super boring. So what we have to do is add a catalyst to make it be all foamy. So we started that to make the foams even more foamy by adding dish soap, but it doesn't do anything. It's just going to be foamy. So, but we have to add something else that's going to be the catalyst. And can anyone tell me what this is? Who wants to give a guess? It's not sand. That's a guess. What do you think?
Baking soda.
Baking soda is white. This is brown. Cinnamon? That's a good idea. It's not cinnamon.
Brown sugar.
No, that's a good idea too. Who else? You guys got any ideas? No?
It's brown baking stuff.
Brown baking stuff?
It helps with bread.
Yes, it helps. Yeah, very good. Okay. Yeast. Does anyone know what yeast is? Yes, you do? You do? What is it? It's like an activator. Is that what you're going to say? Yeah? Who else has got anything else about yeast? It's what makes bread rise. That's what yeast does. So we put in a tablespoon of that. Plus we're going to put in 3 tablespoons of water to help the yeast get going. And this is just water. Nothing else in it, just water. So we're going to give it like 30 seconds. I'm going to give it another 10 seconds and then I'm going to pour it in. And what's supposed to happen is this, it's supposed to get all foamy and look like toothpaste. Right? By people who have already seen it? Do you think, did the YouTube one go crazy straight in the air? They use, I'm going to tell you right now, it's not going to look like that because they used a much higher hydrogen peroxide than I can get, like without a permit. Yeah, Lucas?
On YouTube, they used a thermal camera and elephant toothpaste gets really hot.
Yes. This does get hot. Okay, you guys feel like you're ready?
Yes.
Okay.
I'm hiding.
It's how the chemicals react creates heat.
Have you ever made a baking soda volcano and then put your hand over the top of it? It gets warm.
I guess styrofoam was not the best option.
It's coming up.
It is coming up, but unfortunately,
There's a lot of.
styrofoam in this cup got all stuck on the bottom. So
Oh
hold on a
no.
second. We're going to do it again.
Oh. Do you guys see it?
It is. And this doesn't even have all the yeast in it.
Wow.
It looks kind of greenish.
Well, because why does it look greenish blue?
Because those are the colors
Yeah.
that you put in.
They are the colors you put in. We're just doomed.
I know.
And then I gotta put in the dish soap. And then, what do you think? Should we do different colors this time? Red and blue? Red and blue? What is red and blue? If you mix those together, what do you get? Okay, you guys ready? All right, so do we think this is gonna be a better explosion than the last one? 12% should be better. It's still not going to go up into the sky. Don't get excited.
What about 1,000%? Would that go up into the sky?
Yes.
It doesn't go past 100%.
But if 1,000%, it would definitely go up into the sky.
It can't go into the sky if you throw it up into the sky.
Okay.
That's like Toothpaste.
I told you.
That looks so sad.
Looks like Aquafresh.
It does look like that.
It's satisfying.
So you can actually see on this one too, it's still going, kind of, slower. You want to eat it? It does look, especially with the colors in it, looks kind of delicious.
Mix it with the green and blue.
If we mixed it together, I think it would be brown.
Do it.
No.
I think do it. No.
So that was pretty much the end of us doing elephant toothpaste at the rec department, and we moved on to part 2. So this is the part 2 that you had to wait for, which is Mentos and Coke. So we're going to do the Mentos and Coke experiment next. So I hope that you guys can join us next week for round 2 of explosions at the park and with Miss Denise, and thanks to the Parks Department for inviting me and having me hang out with them for a morning. And we will be bringing you, I think, one more video after the Mentos and Coke experiment, because I'm going to go to the rec one more time and we're going to do an art project. So you guys come on back next week and have a lovely rest of your day. Bye.